Welcome to bite-sized tutorials where we break down complex topics into quick, easy-to-digest lessons. I'm starting a new series on large-scale distributed systems. We will explore the ideas and challenges behind the systems that power modern apps and services. These systems are everywhere, whether you're streaming a video, shopping online, or using a social media app. Let's start with the basics. What are distributed systems? Imagine an online shopping app during a massive holiday sale. Millions of users are browsing products, adding items to their carts, and making payments, all at the same time. No single computer can handle this level of traffic. Instead, the app relies on a distributed system, a network of independent computers or nodes working together to share the workload and deliver a seamless experience. In a distributed system, nodes often collaborate to handle the same types of tasks, like processing logins, managing shopping carts, or handling payments. These tasks are distributed and often replicated across nodes, ensuring the system remains fast, reliable, and capable of handling millions of users, even if some nodes fail. Distributed systems solve many big problems. They scale by adding more nodes, they stay reliable because if one part fails, others take over, and they're fast because they reduce the workload on any single machine. But they're not without challenges. How do you make sure all nodes have the same data when they're spread across the world? What happens if a node or a network link fails? And how do you keep everything synchronized when multiple tasks are happening at the same time? These are the kinds of problems engineers solve when building distributed systems. In this series, we'll explore a wide range of topics. We'll start with the CAP theorem, which explains why distributed systems can't achieve everything perfectly. We will dive into data replication, sharding, and consensus algorithms. We'll also look at caching, load balancing, and distributed transactions. Beyond these core ideas, we'll explore advanced topics like CDNs, edge computing, high availability, and DNS-based routing, which bring distributed systems closer to users and improve their resilience. In the next tutorial, we will focus on the CAP theorem and the trade-offs it forces us to make when designing distributed systems. Stay tuned.